Hello everyone, happy Tuesday. Today is Tuesday, March the 24th, and I'm posting this video so that we can start a new unit today. We need to talk about and revisit the topic of specific heat capacity. We very briefly talked about specific heat a couple of units ago when we were talking about water and the fact that water has a high specific heat constant. It takes a lot of energy to change the temperature of water because of those really strong hydrogen bonding intermolecular forces. So anyhow, today we're going to be revisiting specific heat and the equation of Q equals mc delta T. We're going to be practicing calculating specific heat, and we're also going to practice doing some conversions with units of energy like joules and calories. It might be helpful for you to print copies of the practice problems before you continue watching this video. I am going to do a couple of examples in the practice problems. Please know that there are 2 pages of practice problems this time, and you will need to complete both pages of practice problems and submit those to me sometime today by 11:59 p.m. If it's the easiest thing for you, you can certainly just take a screenshot of your work and just send that to me in a message or in an email. But I would like to give you some completion points for completing those practice problems. Hope you're doing well. Hope your classes are doing well. I am going to turn my camera around so that my camera focuses my notepad so that I can kind of write as I'm explaining what's going on. So the equation that we looked at a little while ago is Q equals mc delta T. Q in this equation stands for heat or energy. M, of course, is the mass of the sample. That will probably be in grams or maybe kilograms. C is the specific heat constant, and this is our main focus for today. I want us to take a closer look at specific heat. And then the delta T is your temperature change, which remember will always be the final temperature minus the initial temperature. And degrees Celsius works perfectly fine with this equation. Now this specific heat constant, I've always thought to myself that they call it specific heat for a reason, because it's something that's very, very specific. It's a value that tells us exactly how much energy it's going to take to change the temperature of just a 1 gram sample by 1 degree Celsius. So it's specific for the mass of 1 gram, and it's specific for a temperature change of 1 degree Celsius. Every pure substance has its own specific heat constant. For example, let's talk about water again. Water has a high specific heat value. It takes 4.184 joules of energy for every 1 gram raising the temperature by 1 degree Celsius. It takes a lot of energy to heat up water. I'm sure that this is something that would make sense to you just from your common everyday experiences. We've completed a couple of labs recently where we were kind of standing around a hot plate waiting for some water to heat up. It takes water a longer period of time to heat up because it takes a lot of energy to raise the temperature of water by just 1 degree Celsius. And that has to do with those strong hydrogen bonding intermolecular forces. Another chemical, on the other hand, let's just use aluminum as an example. Aluminum has a much smaller specific heat value. It doesn't take nearly as much energy to raise the temperature of aluminum. It only takes 0.89 joules of energy per 1 gram mass just to change the temperature by 1 degree Celsius. If I had a sample of aluminum and a sample of water sitting right next to each other in the sun, same masses, of course, we know that the aluminum would heat up really, really quick. The water takes a much longer time. So specific heat helps us to know why and whether or not something's going to heat up really, really quick or a little bit slower like water. Now let's look at our practice problems. I'm looking at the page that has Q equals MC delta T, that equation written across the top. And notice on this page I've circled the even numbers. Those are the problems that you will need to complete. Let's just use number 2 as an example. Number 2 says, what is the specific heat of aluminum if the temperature of a 28.4 gram sample is increased by 8.1 degrees Celsius when 207 joules of heat is added? I'm going to make a list of all the information given in the problem. We know the mass is 28.4 grams. They're talking about a temperature change of 8.1. The amount of heat added is 207 joules. They're asking us to calculate the specific heat value. So I'm just going to do a little bit of plug and chug with my Q equals MC delta T equation. Plugging in Q, plugging in the mass, C is what I'm solving for, plugging in that temperature change. Mathematically, you'll need to divide both sides of the equation by 28.4 and divide both sides by 8.1. In my calculator, I would type 207 divided by 28.4 and divided by 8.1. And you should get about 0.89, which actually is what I just mentioned above. I said 0.8998, and that would be labeled joules per gram degree Celsius. So it doesn't take as much energy to change the temperature of just 1 gram of aluminum by 1 degree Celsius. Now, the other thing I want us to look at, the second page of practice problems, I want us to look at some conversions with some different units of energy. We mentioned that the SI unit for energy is joules, but sometimes we might also encounter calories. That's the little CAL on your worksheet, or even kilocalories, which is that big uppercase letter CAL. There is a difference between the lowercase letter c and the uppercase letter C. Number 1 says convert 105 joules of energy to big calories, the big CAL. This is going to be a multi-step calculation. First, I'm going to get rid of joules, converting to the little calories. And then I'm going to add one more step to get rid of the little calories, converting to the kilocalories. And I'm just using the information, the relationships across the top of the page. 1 little calorie equals 4.184 joules. And then there are 1,000 of the little calories in 1 kilocalorie. Again, that uppercase letter C, C-A-L, means the same thing as kilocalories, which, by the way, is also the same thing as nutritional calories. If you were to look on the back of something, I don't know, maybe a granola bar or something that you were going to eat, the calories listed are actually kilocalories. Nutritional calories are the same thing as kilocalories. So all you're doing on the second page of practice problems, the entire page, all you're doing is just converting with different units of energy. Again, please make sure that you complete the practice problems. I will have answers posted for you on Thursday so that you can definitely check your work. Reach out to me if you have any questions at all. I'd be happy to help you. I hope that this makes sense, and hang in there. We're going to get through this together. Thanks so much for tuning in and watching this short video.